So in this problem, we will be doing Na2HPO4, which is another salt. The reason I know it's a salt because when this dissolves in water, you're going to get Na+. You're going to also get Na+, you're going to get two of them. And you're going to get HPO4. And HPO4, since there's a +1+1, this is going to have to be -2 to make that neutral. So understanding this phosphate ion here, so you know that phosphate has a -3. PO4, -3, you memorize that. Which means it can take up to 3 H's to make it neutral. Each H is +1. Okay? The Lewis structure looks like this. Here's a PO4. It has the HHH, neutral. Which means the HPO4 -2 has lost 2 H's. So this is gone, and this is gone. And what you have here is a lone pair that's ready to attack. Here, ready for the H+ to go back in. So this is gone. Okay, so as you can tell, this substance HPO4 -2 can take an H in this position. Let me just erase this better. It can take an H in this position, and it could also lose this H. So this HPO4 -2 can be both an acid and a base. It's called an amphiprotic, which means it can accept a proton or give a proton. Okay, so I'm going to write that here. So HPO4 -2 can hydrolyze as an acid, and HPO4 -2 can also hydrolyze as a base. And the only way you'll know which one it'll do more is to figure out which is bigger, the Ka of this acid or the Kb of this base. Whichever is bigger will tell you whether it's acidic or basic. Okay, so let's do the reaction. So this becomes, as an acid, it wants to give away the H. So you're going to get PO4 -3 plus H3O plus or H plus. Okay. As a base, it'll take an H plus, and you will get H. It used to have 1, now it has 2, PO4. So as an acid, it'll take 1 H right here in this position maybe. Okay, now you have a -1 because you added 1 plus proton plus OH minus. So you have the possibility of it producing more OH or more H plus. Whichever wins is going to make the solution either acidic or basic. So all we have to do is get the Ka of HPO4 -2. So you look that up in this chart, Appendix D. So you're looking for HPO4 right here. So it has 3, Ka, Ka1, Ka2, Ka3. Which one do we want? I don't remember. I have to go back. Okay, so it's HPO4 minus is the one with only 1 H left. So you're removing the third H. So you want the Ka3. And that is not going to be likely. Remember, it's harder and harder to remove the acid, the H's. So where is it? H3PO4 right here. There's A1, A2, A3. 4.2 E -13 to remove that H. (4.2 E -13). What that tells me is that this H plus does not want to come off. Okay, it's too low. Now let's do the Kb. If you try to find the Kb for this base, you won't find it, remember. So what you have to do is use the formula Kw divided by Ka. Remember, because Ka times Kb is Kw. So it's 1e negative 14 divided by Ka. So which Ka are you going to use? This is the base, which means this is the conjugate acid. So you have to use, this is the Ka2, because you're removing the second H. The first one already came off to become that conjugate base. So use the Ka2. So Ka2 is right here. Here's Ka2, 6.2 e negative 8. So it'll be equal to 1 e negative 14 divided by 6.2 e negative 8. Kb is equal to 1.6 e negative 7. Okay, so comparing Kb and Ka, this is bigger. What that means is that this HPO4 minus 2 would rather be a base than it is an acid. So this will be, when you drop this in water, your solution, see it's a bucket of water, will be quite, the base wins, so it'll be basic. You'll have a basic solution.